And this problem, this unsolved problem in the origin of animals, is well known within the discipline of evolutionary biology. Wallace Arthur is an English developmental geneticist. I met him when I was a graduate student in Chicago. And in the late 80s, he was becoming very unhappy with textbook theory. And in a publication at that time, he said, "We don't really know how body plans originate. And the examples we have in our textbooks aren't adequate." So what he calls there Biston betullaria, that's the Linnaean name for the famous peppered moth of England, which many of you may remember from high school biology. This is a classic example of natural selection in action, where pollution changes the color of the environment such that the light-colored moths are preferentially preyed upon by birds because birds can see them, where the dark-colored moths have better camouflage. And what happens in that process is the whole population shifts. It's an example of natural selection, but Arthur says this really doesn't explain where the moth itself came from. Eric Davidson at Caltech up in Pasadena, in a paper a few years ago, said, what we see with things like moths versus the question of where moths came from, these are fundamentally different problems, as different as apples and oranges. And we cannot understand the origin of the moth itself just from the small-scale evolution that we see. Well, you can go back in the history of evolutionary theory in the last century and find the point at which the mistake was made. Now, it wasn't really a mistake. Anytime you do science, you have to make assumptions about the world. And the founders of textbook evolutionary theory said, let's assume that micro, or small-scale evolution, and macro, or large-scale evolution, are the same. Just add time to micro and you'll get macro. Dobzhansky, who was one of the founders of textbook theory, in the mid-30s said, we can't observe macroevolution. It took place over a long time. So what we have to do is take microevolution and extrapolate that over time. And he said, we'll do this reluctantly. We'll put a reluctant sign of equality between micro and macroevolution, and we'll push our investigations as far ahead as we can on the basis of that assumption, or what he called a working hypothesis. Now, the thing about a working hypothesis is it can turn out to be false.